Let's talk about interference. And to demonstrate interference, basically, I'm starting out with a wave right here. This represents a wave. If this is sound, this is the points of high compression, and these are the points of rarefaction, and just normal air pressure would be right there in the middle. So compression, rarefaction, these are the points where the eardrum gets pushed in. These are the points where the eardrum is pulled out. Now, if this actually were a sound, because I generated this, I had a whole bunch of numbers that generated, basically it's a sine wave oscillating up and down. This would be a pure note if this were representing sound. But this can also represent any other type of wave. It can be a transverse wave where this is the physical, motion of a particle moving up and down as the wave is moving across. There are many different things it could represent. So it represents any generic wave. And what I did to demonstrate this is I put it underneath the transparency material right here, and then I traced it as best as I could. And so I put it underneath and I traced it using a Sharpie. And so notice how that the lined up easiest, I think, to look at the peaks here. The peaks start out the same, and the peaks near the end are pretty much the same. And so this would represent, if this were actually two waves, the transparency and the paper underneath it were two waves, if they added together, it would be twice as loud as just one of them. So I then generated a second wave looking like this. Now, on the surface of it, to me, they look pretty much the same if I was just doing this by eye, because there's really a very subtle difference between the two. And so I wanted to see what would happen if I actually combine them. And so I'm going to combine them using the transparencies. The magic of transparencies. And I'm going to line it up again. And notice what happens. We start out where the peaks are pretty much completely in sync. So this is the second wave. That's the white piece of paper. It's the second wave, and the transparency here is the first wave. So they start out together, but as time goes on, as we get closer, notice that the peaks are no longer together because they're slightly off. Now, what happens if these two waves actually combined? Well, as they combined, when they're both compressing, when both compression waves are completely in sync, well, you get twice as much compression and it sounds twice as loud. At the points where it starts getting less so, well, you start getting a drop off in the compression, because where one is hitting its peak of compression, the other one is not quite there. And so the combination is not quite as strong as where we start. And so we just add them together. This is known as the principle superposition. We add them together, and it produces something like this. Before, they both peaked around 1, and so now they're peaking around 2. But over time, it starts to drop off. That over the course of these particular, over that duration, it's not quite as strong here. If this were sound, this would be a whole lot louder than this. If this was vibrations on a bridge, this would be vibrating a whole lot more than this would. So if I take that even one step further and just extend it, well, we start out with the same thing as we saw before, but it starts dropping off, until we get to there. Notice we have here the sum of the waves is greater than each individual one. This is constructive interference. And then it starts getting less and less. It's still constructive up to a certain point. And then when we get to here, it's destructive interference, destructive, constructive, destructive. At this point, they basically cancel each other out. And so what we have is if this were sound, it would have this really loud sound, the wow. And then down here, it sound like nothing. So you get the wow. Do that in another video where we actually use a sound generator for that. But this is, in essence, this right here is demonstrating beats, and the overall principle is constructive and destructive interference.